All right, the recording is up. So let me start off with the official welcome for everybody. Welcome to the Sunday Night Call. If you're new here, hopefully you'll find something valuable and you come back again. All of our previous videos are up on YouTube, so you can go back and check them all out. I think we might be on the 23rd video now, 23rd Sunday Night Call. And I'll go over this at the end too, but if you are interested in giving a presentation, we want any team, any student, any mentor who wants to lead a discussion, give a presentation. If you're a potential Dean's List candidate, this is a great thing to have on your Dean's List essay if you're interested in leading a conversation. And so there's a sign-up form. While Isaac's presenting, I will post the sign-up form. And if you got the link to this call from someone else and you're not on the mailing list, I'll post a link to sign up for the mailing list too. Other than that, Isaac, tonight's your show, so take it away.
Okay, so, sorry, just don't always see the blue box and meet. So today, it's gonna be very CAD heavy. I'm going to be going over a Medtronic Jumpstart presentation on designing for manufacturing. So if you guys have any questions or feedback, especially because this is the first time doing it in front of a group, that'd be very beneficial at the end. And also I have some questions for just other people who do CAD. But that's after I present. Let me just get that pulled up here. And this is supposed to be about 30 minutes, but it's maybe going to go 40 to 45. Practiced it earlier and it's 50, so that's well over the jumpstart time. Okay, so design for manufacturing and assembly. I'm Isaac Johnson. I'm with Team 2052 KnightKrawler. Bit about me, I'm on the build sub team. I am this year's CAD CAM lead. I'm also a junior and joined my freshman year. I've been doing CAD since my freshman year and spent build season in Cicada's CAD, which is a robot, this last year. So I'll be covering design for manufacturing, so using CNC milling, 3D printing, specifically FDM 3D printing, and then manufacturing by hand. I'll also be going over designing for assembly, so that's making contacts, which is a more OnShape thing. I'm not sure if other CAD programs have them, but I'll get to what they are later. I'll also go over just making sure you include how parts connect, accounting for fasteners, other parts, and other connections so that nothing tears itself apart. So designing for manufacturing. So on KnightKrawler, we like to do all of our manufacturing in-house by ourselves. So to do this, we have three main options. CNC milling, by which we use our CNC. It's an Omeo X8, that's top right corner picture. FDM 3D printing, we have a couple printers that we use. And just by making stuff by hand, also with power tools, mainly power tools. But yeah, a lot of the parts we make can be done in a couple different ways, but a lot of the time, 3D printing will be the only option, say if it's a really complex 3D object. But moving on. So before we actually manufacture a part and design it for that process, we need to figure out what our method we're going to be using is. And so to determine that, we need to know its requirements, like its strength, flexibility, or how rigid it is. It's kind of a spectrum. Then the precision that we need for this part. So, for example, if you need a really strong part that is really rigid, then it'd probably be better to go with a CNC aluminum plate, and as opposed to if you needed a weaker, smaller, really flexible part, that'd be better off for 3D printed say you're making a mount for a camera or something. We can also determine what process we use based off of the size, shape, and dimensions of our part. So if it's like 2 feet by 3 feet, it really your only option is doing it by hand or to CNC it. But at any point of the process, really, you can look at the requirements of the part and just the aspects of it to determine what process you're using. So I've got an example part here. It is a 60-degree elevator bracket. And so this was for our 2023 robot. And so this needed to be strong and inflexible, able to take a hit and not bend, because it's going to be what's holding our whole elevator assembly and basically how our robot scores. So very important. It needs a precise 60-degree angle. It needed to be 10 inches by 12 inches roughly. And it's very flat and thin, no 3D elements. We made this for CNCing. So before we can talk about what to design for doing CNC manufacturing, we need to understand how it works. So we CNC mainly wood, polycarbonate, and aluminum. And so we use big sheets, so like roughly 2 feet by 3 feet is what we can fit in our CNC. And so we cut it out using G-code by importing a part from our CAD file to a CAM software. We use Fusion 360 for that. And then CAM software converts that to G-code to drive our 3 axes of our CNC. And then to cut out the part, it uses a spindle which has a really long and thin bit. And then I went over bed size, but we also need to hold down our part to our CNC so that it stays in place and so it doesn't damage our bit. So using our CNC, we can create many sizes of parts ranging from like around an inch to a couple feet across. And they are also pretty precise, especially when we've got our tolerances dialed in. So to actually design for CNC milling, we've got a couple things we need to keep in mind. And this is best to keep in the back of your mind through the entire process. So we need to keep our parts flat, and you need to like measure what stock you have. And just anyone not aware of that terminology, that's the material you're cutting your pieces out of. So you need to measure the width of your stock, because it could be like if you take a 1/2-inch piece of plywood, it could range from 0.45 inches to 0.55 inches. So you want to be really accurate on that end. And so then we need to have a part that is within the cutting area of your CNC. So that's typically a couple feet across and a couple feet deep. Then you need to like add in clamp down holes. These can be just holes that you need for bolts or rivets or however you're fastening stuff to it. But you'll be using these for putting, if you have a wasteboard like we do, screwing directly into the wood underneath to hold it down and in place. Or you need to figure out how you're going to be holding the piece down after it's cut out if you're not using a wasteboard. Can't help you there. But lastly, we need to account for the diameter of a bit, because this is a round bit going, in this example, a square hole. So if you have any concave areas that are a sharp angle, or even any angle that's concave, you're going to need to account for that bit diameter by making a little half circle in the corners, because if you look at this image on the left real closely, the corners are rounded by about 1/8 of an inch, because that is the size bit we're using. And if you don't account for that, like in this image, then if you need to press fit anything in there, like a was it a piece of 2x1, like in this example, then it's not going to fit very well. Then hold down holes. So this part has many available holes, like we have 13 on the bottom alone. But if you look at the two green plates side by side, you'll notice that there are no holes on the rectangle and circle. And so these pieces, we need to hold them down because that smaller piece could, since it's very small and very light, you could have your bit fling the piece of aluminum across the shop, which is very unsafe. And that larger piece, while it probably wouldn't be flung around the shop, you would have your bit spinning at about 3,000 RPM, crashing into a moving object, and that would likely snap it, and that is not very good. So to account for this, one way is to, in your actual CAD program, or if you're using a CAD program that has CAM in it, just in your CAM program. But anyways, to use in your CAD program, like add a little, I'll call it an island for now, where you have an extrusion for what you're cutting out, and then you have holes in that island so that you can secure them. Then adding a, say, 0.01 millimeter thick channel that is the width of the bit to actually cut into, so that you can export the whole thing into your CAM software. So this like thin channel allows us to export the whole thing as one piece with the islands included. So now if we use a height setting, so we cut out this piece with a contour tool map, or whatever it's called. Anyways, we use a contour tool, and in that, like for configuring that tool, we use about a negative 0.01 inch offset, so that we make sure that we cut through the entire stock, even if we have it slightly off. And so that offset is going to go straight through that extra material that makes up our channel, and it cuts out the entirety of the piece. So we have another example here, and this is a marble wall splitter. Its strength is very irrelevant because it's basically a toy. It needs to be easy and cheap to make because we are putting this on a marble wall for STEM, STEM fairs, and we don't want to spend a large amount of money on this. It needs decent precision because depending on where the marble hits, it will go a certain way, and we want it to be as random as possible. It's a 3D and very complex shape, at least relative to what we're working with, and it is quite small. So this is designed for 3D printing in mind. And the 3D printer that we used in this case is a picture there, but it melts plastic, and that is like a thin tube or coil that you just feed into it. And so it then extrudes that coil using some gears and a hot end, which is about 240 C, and it lays down one layer at a time, just making the silhouette of the object and building up. And then it starts on the bed, and so need a flat face for that, so that it can actually get as much adhesion as possible. And this is also controlled by G-code, so we send it to an intermediary program that figures out all of the operations the machine needs to do to create the part. So FDM 3D printing, it's good at creating like prototypes or smaller parts that aren't going through a lot of force. So to design for FDM printing, we have one goal in mind besides actually making the part, which is to minimize the amount of supports we use. And a support is, if you look down at the bottom right, we have a picture of a couple of a different part, but the green is those supports, and those like go up, and it's extra material that's placed down so you can rest the or rest overhangs on it so that it has something to like lay down on. But we want to get we want as little of those as possible because that is wasted material and wasted time. So if we want to make a overhang or anything that juts out, we want to do inclines. So every layer needs to be supported by the previous layer, but you can, if you go at about 45 to 90 degrees, which is a good, like, it's a good rule of thumb for your incline. So 45 to 90 degrees relative to the bed, it will be able to create a very nice, like, overhang that doesn't need any supports to support it. It supports itself based off of the last layer. Then you can also bridge across gaps, very small gaps, up to like maybe a 3/8 of an inch, I would recommend. But you can also bridge small gaps if you need to like do that, like in this picture here. And also, since we are using a hot end and laying down plastic, it is going to come out hotter than it will cool down. Or sorry, it's going to come out larger than it will end up being. The final product will end up being, because the hot plastic expands and it'll shrink a bit as it cools. So you want to account for shrinkage. That's about I use 0.1 millimeters as like how much it will shrink, and it's worked pretty well for me. You also want to take into account lifting, where if you have, say, it's really bad on rectangles or anything with a sharp corner, where if you have a flat plane or the flat plane of the bed, it'll like heat, or it won't stick as well on the sides, and so it'll lift up a bit, and that throws the like whole print off in some cases. So trying to round corners a bit, and like it can also help to have an enclosure or something, but that's something to be aware of. You're also going to want flat faces so you can get or at least for your bottom layer, so you can get as much adhesion to the bed as possible, and that can help prevent lifting just by getting more adhesion. And you can also print parts, like one part is multiple, like cut it in half and then reassemble with bolts or something. I should probably remove that off of here. But so what the last thing I had on there was orienting for specific strengths. So I have this big picture here is a hanger which parts for the marble wall hang off of. And so they have that little curled like hook, and they have that straight hook. And it's hard to see here. At the end, I can show the picture of it, or I can show it in the splicer, but there it shows little horizontal lines that go all the way across, and these are the layer lines. So these are the layers that the printer will just lay down and keep laying down. And so on the bottom left one, it has layer lines, and it's just the pegs are just stacked up, and that is not going to be as strong as the layer lines of the that's not going to be as strong as the pegs of the parts on their side, because the shearing force is less for breaking off like that, as opposed to a curve breaking off in the middle of it. One other thing of note on this slide is I have a like another part here in the bottom right, and it's printed face up, and then all of the walls print up. That was how it's designed, but it has a like notch on the back so that it can interface with these hooks, and that notch is this rectangle right here, and so it has a hole that is inset from this face of it. So that would give it would make it hard for the machine to bridge. So to solve that, You can also use custom supports where you just have like, in this case, it was a 0.2 millimeter line that goes all the way around, just about like an eighth of an inch apart from the walls. And that allows the printer to build it up, and then it can easily bridge between the like that line so that it doesn't have to go all the way across and potentially cause issues. If there were normal supports there, it would like be all gunky because it would leave little bits that didn't break off, and it wouldn't be as nice of a fit. So last but not least is designing for handmade, uh, or designing for making stuff by hand. So some important stuff here. You want to make sure all your lengths and your placements of things are easy to measure and easy to mark, because people aren't machine accurate and they need references to measure off of. So if you have something that is like 2.5 in the middle of aluminum bar and 2.5 inches down, that'll be easier to mark and drill than something that is say 0.23 inches to the side and 2.3 inches farther down. Also, if you're designing for handmade, any assemblies that you make in the CAD, you're going to want to make sure they're easy to read. This can come in the form of just making it so it's multiple assemblies that are all put together, or you can color code it, which is a personal favorite of mine, as you'll see by the little Tykes colored CNC router table right here. But yeah, you can also use drawings, which are this bottom right image, and you can just make a blueprint for the people assembling whatever you're making. And so if you're designing for handmade or making stuff by hand, then you can leave aspects of the CAD out, like overlapping joints or fasteners. You can just not CAD them and just have them figure it out, or like tell them how to do it. But in this example, this bottom image on the left, it's all made up of 2x4s and 4x4s, and these port poles in the corners are overlapping with the red length bar. So we just need to like make a notch for the red bar there. But yeah, good rule of thumb, simpler parts are going to be easier to make and more accurate in the end. So next up, designing for assembly. So I have an example here. It's custom serve module, but take note of the orange spacers, the bolt holes, the bolts and nuts, the belts, the nubs on the wire, the gear interactions, pretty much everything that makes this an assembly of parts, I guess. But more so how everything goes together. So, one thing before we move on, all these slides have context in them. So in OnShape, a context is just an overlay of an assembly into a part studio, and part studio is where you actually make the parts, and assembly is where you actually put them together. Different from a lot of CAD programs, the two are separated, but a context allows us to draw off of and use the assembly as a reference in a part studio. So to do that, just right click on a part and click edit in context, and the drop down that comes up and should be golden. Okay, so including how parts connect. Stuff needs to connect and be fastened together. It'll just fall apart otherwise. But so to make sure things connect, you should include bolt and rivet holes. Kind of a given, but you should keep in mind to include those when you design something. If you have any big spaces, you should put a spacer in there. If you got any shafts like hex shaft, or if you have like a sim shaft poking through or anything, got to make sure you have holes for that or a bearing hole. And if you have bearings, you want to have some way of holding them down. So more on bearings. There's many ways you can actually keep your bearings and your shafts on, but you can like bolt it down by just holding on to the rim of the bearing. You can put it in 2 plates. So in this top right image, it's just sandwiched between 2 plates. You can use the attachments on the shafts that are attached to the bearing. So you can use like a lock and collar and then some spacers and a gear, or you can like just wedge it between 2 plates. Yeah. Moving on, gotta account for fasteners when you're designing something. Like, just always should be in the back of your head, how am I going to fasten this together? So parts should have like the bolt hole space so that the nuts are like not interfering with each other, like in this image in the center. And you should always account for the the head of the bolt or the nut. And so you can do that by insetting them, like just making a hex cutout for a nut or just making a countersunk hole for a bolt. You can account for how much room the head of the bolt's going to take, like in this bottom left image. And you can just have stuff get out of the way of it. Or if you CNC a part or you have a thicker part in that you 3D printed, then you can like make a slightly smaller hole. I go for whatever the bolts, like the size of the hole for the bolt is, and then subtract a tolerance of 0.03 inches or 0.003 inches. Then you can tap that and just thread directly into the part. And I guess ignore having a nut. Account for other parts. Basically, just you want to keep in mind the locations of any rotating gears and any rotating parts. So in this top right image, I have a bolt and the whole assembly rotates that bolt's connected to. Then that gear, it originally was colliding with that assembly, but I changed the spacing so that it wouldn't. So going back and checking that nothing collides, everything has some breathing room of a good amount, at least like 0.01 inches. But also should keep in mind if you have any extending parts that you don't want anything that they can catch on or that they extend into. Belt paths, I have this bottom right. I wanted a belt to go through a part, but it didn't have enough space to go through, so I just put a bolt through or a couple bolts through that squish the belt. Yeah, you can also use sketches to plan out all of your where all of your parts are going, and see if anything collides that way. If you are looking like at something from a 2D point of view, so I've got a planning sketch here for a turret that I was making for fun. And lastly, gotta account for other connections. So that would be electronic wires, tubes for pneumatics, any cable chains if you're extending. Want to make sure everything is out of the way of any moving parts and gears. Let's see, and gotta account for your solenoids and motor controllers, and sometimes got to see if it's better just to do something electronically instead of mechanically. Like if you're trying to turn something, like go for a motor instead of like hooking up, say, like a rotation mechanism to a forward extension mechanism. Sometimes it's easier just to use electronic solution. And that's all I got. Thanks for your time. Any questions, comments, or feedback?
I think when you were talking about holding down material for CNC,
Yeah.
One of the things that we usually do, I wanted to add to your tips and tricks there was usually we cut our rivet holes with an 1/8 inch bit, and we'll cut all of our holes first, and then we'll pause. So we'll cut in 2 paths. So our first path will cut all the holes, and we'll clamp down the piece of material around the edges. And then once all the holes are cut out with the CNC, then we can go in and we can just use wood screws or machine screws, sheet metal screws, and we can just screw down to our wasteboard in whatever holes we want to use as hole downs. And then we'll cut our contour path, which will cut out the part later. And that's worked really well for us to export our CNC paths in 2 paths, one for holing and another one for all the contours. And then between those 2 paths, we can screw down all the materials using our rivet holes. And sometimes Isaac pointed out we have to add holes in places where we don't plan to have a fastener, simply because we need to have a way to hold down the material in that area. But that's a good tip. It's one of the things that we have needed to get better at, because in 2 years ago, we would design parts and then we would have these parts and get them all set up in the CNC and then say, oh boy, we don't have any way to hold this down. It's going to go flying. But now we're getting better at making holes and preparing ahead of time for CNCing.
I have a question. I think it's on the accounting for a bit diameter slide, on the square parts and rounding the corners. So what does having like those half circles on the edge of the CAD, so when they're cut out, is it like leaving you with a bit that you have to sand down, or is it like, I was just a bit confused by how that fixed the issue that was presented.
Oh, so if you add like the little circle in each corner, that'll make it so that like it gets rid of it gets rid of more material, but it'll get rid of that little curving.
That little rounded part in the corner.
That little rounding part. Not sure if that fully answers. So.
Okay, that makes more sense.
If you want a really nice, pretty corner that's square, you can use a flat file and you can file out the corner. But this just eliminates your need to do anything by hand, because it'll make the corner so your square tube will just slide right in.
Okay, so it's mainly for if you're using tubing. Okay, that makes more sense, because in that application you need that entire square cut out, and you can't have that little bit with the rounded corner left in.
Yeah, a rounded bit's just never going to make you a square corner. And so these corners here that Isaac has are bigger than they would need to be. But another thing that's important with these big round corners is that you never want to be going into a corner where over half of your bit or even 2/3 of your bit is making contact with the metal, because that's a lot of blade that's touching your metal, and it can cause it to dig into the metal, and it can kind of like cause it to suck into the metal. So you always want to have your radial contours slightly bigger than the size of your bit, because then it'll make it easier for it to get through that corner.
This is Eric Schaefer from Talon. If somebody's looking at a new CNC machine, ours comes with clamps, so you might makes things a lot easier if you purchase one that's already has clamps on it.
I'm going to elaborate on that a bit. We never screw down our parts. I'm also part of Talon. So we clamp the stock material to the sides of the CNC. I don't know if the Amios have that capability. Run all of the holes, run all of the contours, and just whatever's left of the contour that hasn't been cut yet holds the part in adequately. If we wanted to cut like a part with really tight tolerances, we would need to, put screws in or something. But we have never needed to do that.
Wait, so if you like, say you're to cut out this part, so you would just cut it out, no screws, then would it just sit there and it's heavy enough to not move?
So when it is still running, there's still material holding it in. It's not fully cut out from the rest of it yet. Once it finishes, it moves, I don't know, maybe a quarter of an inch or something before it hits the side of the remaining stock. And no, it doesn't go flying or anything. Even our small parts have never gone flying. We don't put screws in the middle or anything.
Yeah, and I also know another tip, because I'm Rasmus from New Mythic, and because we also clamp down material, we never use screws, and we always put tabs on the material. So, for those who don't know, tabs are just little bits of metal that just connect the material together. And so we always add those in and then just go in after, just cut those out after it's off the machine. And it does need some filing and some sort of cleanup work, but that's worked pretty good for us.
Yeah, tabs are some CAM software actually has it built in so you can set up tabs as part of the CAM software, and that I agree that is kind of handy if you don't mind doing the filing.
Yeah, it's built in for Fusion at least. What CAM software does KnightKrawler use?
Fusion mainly.
Okay, yeah. Makes sense. I feel like a lot of teams use that for CAM.
Yeah, Aerobot 8878. What's your question or comment?
Hey, so do you guys have a library of beginner resources material for younger people who want to start CADing using OnShape? Because I'm trying to push that on my kids, but that's not my area. I'm not versed in any of that, and I'm trying to learn it myself too. But my thing is I'm very limited on time, and so if there was something easier or something easy to follow that I can push that way, and see like if there's a link that that again, or if there's already a jumpstart material that somebody else have out there, if you guys can link it to the the whatever document goes with the recording, that would be really helpful.
Yeah, okay. I'll look, but I have some stuff that I made that isn't tested. Might not be as helpful as some jumpstart stuff, but
OnShape has a pathway for intro to CAD based on FRC. I linked it in the chat. I haven't gone through it. I briefly glanced at it, and it looks pretty good at getting just the basics down. It doesn't go super in depth, though. It mainly goes into like, designing a drive base.
How do I get to that, Ian?
I put a link to it in the chat.
All right, thanks.
I also have another resource. I'll post the link here. It's in development right now, so there's a lot of stuff still missing from it, but there's a lot of good information. I believe this should be the link.
And as far as setting up what is commonly referred to as feeds and speeds, and that's the speed that you would run your CNC at, or how fast you would run your spindle, all of those things. It depends largely on the machine that you're using, how powerful it is. Fusion has, if you search YouTube, you can probably find some good videos using Fusion 360 for whatever CNC that you have, or someone will recommend if you're going through this this hardness of aluminum at this thickness, this is what you would use for your feeds and speeds. This is what you would use for your step down values, things like that. So we're running an Omeo X8, and we're using Mach 3, right, Isaac? That's what we're using is Mach 3 as our CAM software to run the CNC. Ian and I mentioned this. I think Ian and I both mentioned this a couple of weeks ago, 2 weeks ago, where we both have Shapeokos. I have a Shapeoko in my personal shop, and Ian has one too. And Shapeokos got really good customer support, and they have tons and tons of videos on using it. It's more of an entry level machine. It's not going to be nearly as powerful as well, that's not true. The latest Amio, the most powerful one the latest Shapeoko, the most powerful one they sell, is probably on par with the Amio, but it's going to be more than twice as expensive. But they actually have really good videos too, and their out of the box software, you can basically just run it as is. It's going to be slow, but it's going to be safe. You're unlikely to break a bit if you run their out of the box software at their default feeds and speeds. You won't break anything, but it may take twice as long as if you were dialing in optimal feeds and speeds using Fusion. I don't know if anyone else has any other advice on intro to CNC and how to set things up.
Rasmus, you've had your hand up for a while.
Yeah. I have a bit more of a CAD CAD feedback or CAD advice for getting started. So not necessarily CNC, but I guess I'll quickly say it. And it's OnShape for FRC is a great resource, and that really looks into the sort of FRC applications of CAD and specifically OnShape. And that goes through courses to learn different sort of add-ons and different like libraries for parts. So it's really good resource. I highly suggest it.
I will echo that. OnShape for FRC.com, amazing, great place to go.
Riley.
Yeah. Did you have something?
Oh, I hit the wrong button. I unraised my hand instead of turning my mic on. So I'm going to start with the more on-topic one, and that is a couple more notes on 3D printed part strength. So if you're worried about your 3D printed part breaking, the biggest thing is infill density. If you're running with like a 20% infill, it's going to be significantly easier to break than with 100% infill. And then there are 1,000 other print settings that impact strength by up to like 10%. But you can get almost all the way there with just putting it in the right direction and using the right amount of infill. And then my second thing is, so it's not quite on topic for manufacturing, but when a lot of our CAD people have difficulty with getting started. So like if you know how to CAD, you've gone through all the courses and stuff, and a general idea of what your subsystem is going to be. Like it's going to be a 4-bar intake for the 2022 balls or something, right? And they just get completely stuck on starting the design. Does anyone have any advice for that?
Ooh, let's hear. Do you have first, Rasmus?
Yeah. So on No Mythic, a great sort of start is because we always like we'll be always on a whiteboard, so come with ideas and then sort of narrow down on what the general idea is. So if you're saying a 4-bar, our first step isn't to make any parts or anything. It's to create what we call a geosketch, which just looks at the geometry of the part. And so that'll basically state what parameters we need to say. So let's say this 4-bar needs to reach a certain height. We can get all the geometry started there. And then we sort of start off of that with probably like the biggest part. So maybe we would start with, I guess, the boxy wing or something after that geosketch. And that really makes it clear what the specific parts are that need to be created and what the parameters are.
William, what you got?
This is also more for just general stuff. In the Link I posted earlier, there's a link to a Discord server inside of that called David's Design Server. And it's pretty much just a bunch of CAD people from a bunch of FRC teams. And you can like ask for advice there. They'll give you advice very quickly. And yeah, it's just a pretty good place. There's a lot of good resources there.
So William, that's that docs.frccad.com.
Yeah, and then you go under the OnShape curriculum when you go to that, and then it's like under it's under Learn from the Best.
Awesome. That's a great resource. docs.frccad.com.
Mm-hmm.
I was just going to ask the people that say that they don't screw their parts down. One of the reasons that we found that we had to screw the parts down was because most of the sheet goods we use are not flat. We get, a sheet stock of aluminum, and it has a good bow in it. So we cut our holes, and then we screw the part in place. And because of that, we end up not using slots. And we also cut a lot of thin material, like say 1/8 inch aluminum and 1/8 inch polycarb, which has a tendency to pull up even when you're using a downcut bit. So what do you do in those situations? You can clamp it from the edges, but you can't clamp it in the middle where it's coming up off the build plate.
For us, we largely don't use those materials. We cut very little 1/8 inch, and what we do cut in an 1/8 inch is small parts. But I mean, yeah, I'm sure screwing would be the best way to solve that problem.
And I guess for No Mythic, what we sometimes do, which isn't the best solution, but if we have a big piece, instead of like stopping and putting in clamps and stuff, or putting in screws, if there's an area that we know isn't going to be used, but there aren't any clamps that can get there easily, we'll sometimes just take like a big chunk of metal and just put that on there, which I know isn't a great solution, but it does the job. Of course, it can be a little bit goofy if you don't want to do that while the machine is running too much, or if you do, you want to be very careful about it. But that can sometimes work. Yeah.
For those of you who are already CNCing parts, are you using lubricant? Are you dry cutting? And if you're using a lubricant, what are you using?
I think our machine came with the recommended lubricant, and we've been using it ever since. I don't know what it is.
Yeah.
It's I think cutting fluid basically.
Okay.
Yeah, if it's not cutting fluid, it's not.
What machine are you running at Talon?
Shop Saber or something.
Oh, okay.
And then
It is an oil-based lubricant. I remember that other teams were using isopropyl in the past. Is that as lubricating or?
Yeah, KnightKrawler's using isopropyl. And now Shop Saver, you're running. Is that a 220 machine, right? Is that a single phase, 3-phase? Do you know?
Not a clue.
It's a 3-phase.
Oh, 3-phase. Wow. Yeah, we had to limit ourselves to whatever we could run on a 110 outlet because we didn't have any confidence that we would get the school to be able to run electrical for us.
It took a bit to get that done. We had to pay a bit to get the school to run it, but yes, that was a big part of getting the time to get the electricians in to reroute or put in those lines.
Yeah, I guess that's a consideration for anyone who's looking to buy a machine is check with your school. If you can't get a 220 hookup or 3-phase, which isn't going to be in all the spaces everywhere, finding a machine that's going to be powerful enough to use, but you can run off of 110 is important. You don't want to buy something and realize that there's no place to hook it up.
And for lubricants, because I want to add what Nomothic does here, because we also use an oil, but we also have two machines, because we have the Tormach 770, I think, and then also the X-Carve Pro. So we have CNC router and CNC mill, and we've been very lucky with sponsorships and have gotten grants for those, which has been really nice. But for the router, that we just use oil when we're doing metal. When non-metals, we don't use a lubricant. And then for the CNC, or for the mill, we use, I think it's just compressed air to just like blow the chips away. But apart from that, I don't think there's a lubricant on that. And we haven't really had issues on the mill, but on the router, we sometimes break a decent amount of bits on there. But I think our cut settings might be a bit off there. But, yeah.
Isaac, you did
think-
really well on time. I'll give you that feedback. I think you went faster, and so I think you might be very close to what you need to be for the Jumpstart event. So congrats on making it faster.
Yeah, I need to go back on the recording and see how long it took exactly, but yeah. So I've got a question for any teams here that like do any weight saving, like by cutting out parts or cutting out chunks of aluminum. Do you guys, or if anyone does that here, do you guys have any method of like figuring out how much you can cut off and like how much thickness you need to leave? Or not thickness, width.
I believe you've already heard this, but at MRI, but I'm going to say it for the benefit of the rest of everyone. For the most part, we just guess. And if it's the part that we think is going to need to be pretty strong, we'll use like half an inch line thickness. And if it's not, we'll use down to a minimum a quarter.
And on Nomothic, we generally use, because OnShape has a feature script, which is the like pocketing feature script. And that is good for about half the time. And the settings on there are generally good. I think that's around a quarter as well. Yeah, and then I think we do around a quarter as well for when we do it manually. So similar to you, Talon.
A lot of times we'll switch to poly. It's the idea, do we want aluminum or we want to save weight? If we think we can get away with poly, that's the route we often do.
Well, a lot of our choices for poly are more flexibility than weight. If it needs to be rigid, we'll go aluminum and just pocket it as all get out if it needs to be light.
I think our last year we weren't worried about weight, but years before, weight was a lot more of an issue. This last design, weight was not an issue.
One of the things, if you're working with flat aluminum plate and are cutting holes out to lose weight, one way you can add strength back in is by using a dimple die, which I don't know if you've ever seen like a cargo rack or anything like that. When you've got a round hole and the edges of it are raised, that's a dimple die. So it actually takes your little piece of aluminum and it kind of punches a big die into a smaller die into a big die, and it kind of raises the edges of your aluminum, and that adds a whole lot of strength back into your aluminum because the raised edge on the hole takes the flex out of the aluminum.
Do you need any special parts for that? Or not any special tools for that?
If you've got a press, like a bearing press or anything like that, that's all you need to do. Is it just presses down in between.
I went and checked. The default on the OnShape feature script is 0.3 line width. Assuming we have the same feature script.
Is it the Julia's feature script? I think that's the one we use.
Probably.
I guess a bit on a different note here, but one of the things that you mentioned in the presentation that I thought was really cool was the use of color coding in CAD. Because we oftentimes don't color code a whole lot, or if we do, it's just because we anodize, so it's figuring out anodization colors. But I thought that was a really cool use of that color there. So
Yeah. Another thing I want to add about that is like if it's a polycarb or aluminum piece, generally I'll do like 0.45 transparency for the polycarb just to make it stand out also so we don't accidentally use the wrong material. So just something I found that helps.
Yeah, we always color code to material.
Well, do we have anything else we want to chat about? I'm trying to fill the silence here. I don't mind ending early if we have exhausted our topic tonight, but I also don't want to kick everyone off early if there's more to chat about.
I guess I have another question. Because I know one of the things the Nomothic sort of faced this last year was the 3D printer sort of different sizings when it actually 3D prints, which was very awkward for some of our spacers. We had to reprint a few times. And so I know you mentioned a 0.1 millimeter offset is sort of great for getting that, like, the clearance for 3D printers. Is there a way that y'all sort of figured out that spacing, or is that just trial and error?
Mainly just trial and error. I mean, because it's going to be different for every printer and every setup. Also, it might be significantly different depending on the filament you're using. Because what filament do you guys use?
That's a great question. I'm not the 3D printer guy.
On 3D printing, I learned a few things about 3D printing for FRC yesterday at MRI. People who are laughing saw the so we had an exposed 3D printed part on our swerve base that worked wonderfully in practice when there were no walls and no other robots to deal with. And then they snapped in our first match. So I would recommend against using PLA in an exposed area on your robot. And I've heard that PETG usually tends to have better strength outcomes or carbon fiber reinforced. And then also probably making the part completely solid or more shells and generally not having it on an exposed part of the robot where it will hit a wall.
There's something else. So with even if you're not using your robot even if you're printing something that's not in an exposed area, let's say for a camera mount's probably gonna hold up okay in PLA. But something also to think about is that if you're transporting your robot in let's say a dark colored trailer or in a vehicle that's going to sit in the sunlight in the summertime, PLA doesn't hold up well to heat like that, and you could get a lot of warping or even any type of other failure with a PLA part. And so PETG usually will hold up better than that. ABS will hold up the best for heat, but ABS also has the most amount of shrinkage, at least in terms of like common types of filaments you'll print. I see a lot of people saying, hey, if it's gonna be sitting in a hot car, you want to print it out ABS. I believe Ultraviolet printed the elbows of their arm out of nylon. Nylon's a very strong, but very, very delicate. I mean, you have to be very good with you have to have your settings dialed in really well for printing something like nylon. And you have to use a special printing nozzle.
Ultraviolet used the Stratasys proprietary filament. I can't remember what that. I can't remember what the name is.
You know what? I bet you're right about that. It looked like nylon, but I bet you're right. They have a Stratasys printer, or they had Stratasys printed for them. So I think you've triggered my memory, and I think you're right about that, because I did talk to them about that last year up in Duluth. So it was a long time ago, but I think you're right. I think Stratasys did print that for them.
I believe that Stratasys proprietary filament is probably Ultim.
Yes.
There you go. Nice. But back to in terms of printing tolerances, I will often print a part, and I will stop the printer after the first 5 to 10 layers and test the bolt sizes. Sometimes I'll just print a part that is just to test my hole sizes to make sure I have the right hole sizes for the right slot sizes. And so if you're printing a part and you can get the face that has the hole in it face down, a lot of times it's easy to do just a 3-minute, just lay down the first couple of layers so I can test my hole sizes rather than printing the entire part and then realizing, oh shoot, these things don't fit together. So that can be a nice trick too. But I have also taken my sketch that I used to make my part and then just extruded up a 0.5 millimeter or even a full millimeter and just printed just a sample so that I could test out my tolerances. And then if that's an option for whatever the part is you're doing, it can be a nice way to avoid wasting a lot of time in filament.
And how many teams have 2 material extrusion?
None of our printers has a dual extruder or multi extruder.
Okay, that's where we've had a benefit of an old Stratasys that we have. Our scaffolding is all dissolvable, and that helps some pretty intricate parts.
That is very nice for printing pulleys.
Mm-hmm.
Do you guys print a lot of custom pulleys? Or not even custom, just a lot of pulleys?
Yes, and yes, custom ones. I think most of our pulleys are printed. The only place we don't run them is if they're at risk of like rubbing against a part and heating up to the point of like melting.
Yeah, and another good use for 3D printers are for flexible parts that can be made out of TPU, because obviously those need less, rigidity and not snapping. So like on our 2023 Compbot Snowdrift, we used 3D printed TPU star wheels because we needed them the next day to test because we had an idea and we didn't have the time for AndyMark to ship them out, and because they published their CAD files, we downloaded them and I printed a couple of them that night, and they made it onto the robot because they helped intake the cubes a bit better, and it also allowed us to make them customizable. Like, I think we cut off in one of the later in our spares, they're just not there, half of the spokes on the star wheels, because we found out that having the only I think 4 out of the 8 on there was helpful in how it indexed the cubes and made it so it lined up with the sides of the cubes, and oriented it in a way that was helpful for us. So that was also a really useful application of that. Next time we need star wheels, though, Scott, I'll make sure to ask KnightKrawler.
Yeah, for those of you who missed it last week or the week before, we basically bought out the store, I think, from 2 different manufacturers on Star Wheels, and then we ended up using none of them.
And
It's
this covers.
important to make a lot of spares before your tournaments. I'm not sure, but I think in the fine print, you're not allowed to print anything overnight during a tournament, only because when the machine shop is closed, you're not allowed to do it. So really, it's nice to pre-make your spares before you get there.
Yeah, and yeah, I definitely agree. That's a really good point. I also 3D printers reminds me, because I mentioned this a few weeks ago at one of these roundtables, but Numothic recently got a grant for the Carbon X1 from Bamboo, and we just got it the other day and unboxed it. We haven't played around with it a whole lot, but it seems really nice. And it's insane how fast it prints. So
Yeah, I will be very curious to get some feedback on how great it performs, because it looks, everything I've seen online looks awesome with the Bamboo.
Yeah, and so far it seemed really great, but right now we've only done a few test prints with it. But no. Now I guess another question, because I remember over the summer, because Nomothic met with Nightcrawler to talk about sort of design processes, and I remember one of the things y'all mentioned there was the sort of how y'all split up the documents into like a bunch of different documents for each subsystem. And I could be wrong here, but I thought that was really interesting because for Nomothic, we generally just use one document and then everyone's making changes on that. So I thought that was really, really interesting. And so I'd be curious to hear sort of more about the process there. And I could be totally wrong here.
Oh yeah. So for our this year's robot, we have, I believe, 35 copies of it at this point. But let me just pull them up. But yeah, I mean, it was mainly earlier on just to test a lot of different versions of like how we would do stuff, like 50-degree elevator, like if someone had an idea for like a certain type, like a vertical 4-bar instead of horizontal, or like a linear extension, like it was just easier to like make a new copy and then make a new copy instead of having to like work in the original document, because then there's the original document's cleaner. There's less people working in there, so if someone changes something that a lot of things are dependent on, doesn't screw much up, or that wouldn't happen, because yeah.
We learned our lesson from 2022. I think last year we had 6 or even 8 students working on the CAD for the robot. We wanted to let anybody who wanted to, try something out and see if they could come up with something better to do that. And in 2022, everybody worked on the same document, and it we ended up having things get messed up and having to revert and go back through the version history and try to figure it out. And so this year we tried something different. I think that we could do better. Like Isaac said, we've got so many copies, and we should do a better job of kind of cleaning up those copies that we've sort of abandoned and said, okay, that idea didn't work. But it was kind of nice that Isaac was in charge of the main copy. And then if someone made a part that looked like it was going to work, we would export that part out, or would not export. We would copy that part into the main document. And then Isaac would bring that into the assembly, or bring the assemblies into the main assembly. And so having only one person in charge of the primary CAD model did work out better for us. But then it also allowed other students to just make copies, and they can play around with different geometries and stuff. And if we found something that worked, and that students, let's say that the electrical board, right? We had students design an electrical board. We took the student who had the best electrical board, and we brought that into the main copy and imported that part in, or copied that part tab, moved that part tab. I forget what OnShape calls it. I think you move that part tab, part studio, into another document, and that made it really nice to be able to keep that main document nice and clean, and have one person in charge of that.
Yeah. Oh, something else we did is at one point in the season, I made like a cicada accessories document, and that was just for like stuff that was on the robot, but it was more like accessories, I guess, like 2x1 caps. I've got the we have a spring on our elevator, so I've got the reel for that. Like, it's a custom reel, so that's in there. Also like camera mounts. So, I mean, it's just another thing to think about.
And something we do is like our drivetrain, elevator, and arm, and I think intake are 4 separate assemblies that are then mated together. And that is largely for performance reasons, just so that you're working in a smaller assembly.
Yeah, I will echo that. I'm a big fan of having your subsystems be their own assemblies. And then you bring those assemblies into a main assembly. I started doing that for some side projects, and man, I just love that way of isolating it. Like you said, not only for performance, but it just makes things simpler when you can tie in like a whole intake arm. It's got all the shafts and the spinny bits and compliant wheels and everything in just one smaller assembly, and having that all in one big assembly with all of those mates and everything in the main document.
Yeah, I agree, because Numithik does something similar there, and it's really helpful. But I guess also one of the reasons I bring this up, which I have a follow-up question, but something that's kind of funny is Numithik, we have probably about 10 people interested in design, which is going to be a fun challenge out this year. So we'll probably have to look into how to sort of split that up. But I guess a question with that then, because you mentioned with, like, you'll have a few different ideas going at once, and then the sort of best of that idea will get added in. So do you all sort of have a few different concepts running at once, or do you have one main one that's going?
This last year, we really didn't have multiple running at once because we were more focused, and also it was smaller group doing it. But
we did have some early concepts with our final robot had a 4-bar mechanism that was controlled by pneumatics. We also said some early concepts where we had a slider that went straight in and straight out, and there was a 2-bar slider and a 3-bar slider. So there were some early concepts that we did where there were sort of competing designs. And like Isaac said, early on, we started with a 60-degree elevator. We tried a 50-degree elevator. And so those, had different assemblies. But I think last year we kind of set it on a final design pretty early. things that were different of where do we want to put the electronics. We CAD'd our electronics for the first time ever last year. We had never put our electronics into CAD before we actually put it on the robot. So that was one where we had a group of students who didn't have anything to do. And we're like, hey, you 4 students, go figure out what the best way is to lay out the electronics and then come back and pitch your plan and tell us why you think it's the best plan. And that was a great project for some students that were looking for a task. And it worked well that way.
Yeah, I will add on to that. I think we also CAD'd our electronics for the first time this year. It was also our first year doing a full robot CAD. But because we had a smaller frame perimeter than we had ever worked with in our team's history, we decided we were going to, and it was our first time using pneumatics, which is obviously a lot of space extra on the robot compared to when we hadn't been using pneumatics. Well, first time since 2016, so for intents and purposes of the students on the team, first time using pneumatics. So we basically it gave electrical team something to do early in the season when there was less to do. So we looked at kind of like the CAD of other compact robots and how they CAD their electronics, and we CAD'd a few different options, and I think that helped us create a really neat wiring situation in our competition robot, at least compared to our previous years, where it was much less of a rat's nest of cables and motor controllers going everywhere. And our team is also, the way our electrical team's set up is also a little weird because as of right now, they're in charge of the swerve modules. So that is another thing that they'll have in early season.
And I guess that's really interesting to hear about electronics, because actually speaking about swerve modules there as well, because for No Mythic, something we tried last year, because last year was our first year doing swerve, and so what we did there is we sort of over the summer created a swerve drivetrain CAD model, and then that had all swerve modules in plus a CAD'd out electronics board there. And so when it came time for the season, we just took that, made a few edits, and then went straight from there. And then we had an electronics board that could just be created with the drivetrain and go straight to programmers. And I think last year it was the earliest we got the drivetrain to programmers, which was really nice. So I guess that's one thing that's interesting here. So.
Yeah, and this year, at least I'm pushing for it. Our electronics sub team, which is like not too many people, being in charge of the entire drive base. Because specifically in those first weeks, our build sub team is usually busy with prototyping and designing and all of that, versus with the advent of Swerve, a lot of the drive base comes down to, wiring, getting all the motor controllers there, getting all of those pieces together. And I guess to some extent, cutting tubing for frame, which isn't, too difficult for anyone to do. And so I guess it adds more to a sub team that regularly doesn't have things to do. The way Swerve ended up in electronics hand is because build was busy the week we had Swerve modules, and because we were trying to do it a 2 or 3 week, I guess probably 4 week transfer. I don't know, it was a short time frame. We were trying to transfer our robot on Swerve before the state tournament. It didn't end up happening, but the first step of that was getting Swerve done as soon as possible. So electronics were the people who were available to build the Swerve. So we built the Swerve, and then it's kind of now the electrical people are the people who know how to maintain the Swerve module and know how to service it and assemble it and take it apart and reassemble it and all of that. So it's kind of just happened that way, and it's not too big of a mechanical challenge.
Well, I think we did it. We made it the full 90 minutes here. We got 5 minutes left. I want to use that last 5 minutes to pitch signing up for topics. currently, next week, we're going to do a mini trials Q&A. So that'll be the official Q&A from the folks who put on mini trials. So if you're participating in mini trials or you're just interested in doing more game analysis as practice and preparation for January, next week we'll do a mini trials Q&A. I doubt that that'll take the full time. So if teams want to share things that have come out of any design meetings that they've had, or anything else they're thinking about the game, I'm confident we can fill the rest of the time with that. But it'll be interesting to see what questions come up in that Q&A to get better feedback directly from the people who put together the game in terms of what their goals were, maybe, or clarify some of the rules and things. So that should be an interesting meeting. Following that, though, we don't have any topics yet for the next 2 weeks. And then there's 1 week in November that's still open as well. So between now and December, we have 3 open slots. Yoji Shimizu is going to be doing a core values talk on November 12th. If you don't know anything about his core values talk, or your team has never considered identifying core values for the team, highly recommend that. KnightKrawler went through a core values session, I think 6 years ago, and we use our core values for everything we do. So I highly recommend that on November 12th. But if you're interested, October 29th, November 5th, we still have openings there. So if you'd like to host a talk, pick a topic, any topic, give a presentation like Isaac did tonight, please sign up. The link is in Slack, or in the Google Meet call here in the comments, but it's also on every email I send out for the Sunday night email list. All right. Any final thoughts before we wrap things up tonight? I upload our video to YouTube.
I might do a roundtable in 2 weeks on electronics, because that's an area that we really need to improve on, and we could really benefit from hearing on other teams. So we would not be sharing our electronic policies. You don't want our policies. I think we broke all but our electrical broke all but 2 matches in MRI. So
I will share that sentiment. No one has ever come up to KnightKrawler and said, "I love the way you guys route your wires." So I would look forward to having some feedback there as well. I know that robots. Every time I see a robots robot, it's so pretty. The way they run their wires, everything is so pretty. Maybe we can see if we can get some robots on here for that talk. That would be great. Yeah, it sounds like a great topic.
I have some experience talking about wiring, but also I don't necessarily feel qualified enough to give a presentation on best practices. But I could definitely help contribute with the things that 926 does.
Back in the day when there was it was like Jumpstart. I forget what it was called, but it was at the U of M. Robots gave a talk on wire management that I attended. That was a long time. It was way before any of you guys were in high school. But the robots, I don't know. There's something special about the way they manage their wires. Well, I'll reach out to their head coach, John, and see if we can get some of them to participate in that conversation. But Riley, that sounds like a great topic. All right. Well, I will see everybody next week. We'll talk about mini trials, and hopefully some of you will be inspired, like Riley is, to sign up for a talk and fill out our calendar. Thanks again, Isaac. Hey, congrats. Good job. I hope you got some good practice there and you feel good about your Jumpstart presentation. All right. Good night, everyone.
Yep. See you guys. Oh, and thank you, Ian, for taking notes. Did he leave? Yeah, he left.